There's another way that we can also communicate what the solutions of an inequality are. It's called interval notation. Now remember, we were able to graph these using a graphical solution. And interval notation is, or how we use the interval notation is, I look at the endpoints of where the solutions are at. So for example, in this first one, I have one endpoint at 3. The other endpoint continues out forever towards negative infinity. So I'll put negative infinity, put a comma between those numbers, and then I'm going to put a soft bracket around both of those. So this is not a coordinate point. This is in terms of interval notation, this tells me all my solutions are between negative infinity and 3, but they don't include 3. And then with infinity, we'll always put a soft bracket around that because we can't pinpoint infinity down to a precise spot. Well, how does interval notation look in our second solution? Well, this one, I look at my endpoints where my solutions are at. One is -1, the other one's positive infinity. Separate them by a comma. Now, I told you earlier that with infinity, it always goes with a soft bracket. Contrasting here, notice that -1 is a solution. So I'm going to make that a hard bracket. So this is interval notation communicating that all the points between -1, including -1, to positive infinity satisfies this inequality. Now, what about this compound one? What do you think? Again, look at our endpoints, -1, 3. The -1, is that a solution? It's not. So I'll put a soft bracket on that. -3 or 3 is a solution. So I'll put that's right, I will put a hard bracket on that one. So this is the interval notation, or a way to communicate the solution to an inequality. Both are fine, but we need to be able to understand and use both and interpret what both of those mean.